Good afternoon, and welcome to the Innovative Traffic Management session as part of Penndot's first ever virtual Innovation Week. Thank you for joining us today. My name is Danielle Klinger-Grumbine with Penndot's Bureau of Innovations, and I will be your host for today's session. Following each presentation today, there will be a facilitated question and answer period. If you have any questions for our speakers during today's session, please use the chat box on the right-hand side of your screen to submit your questions. We will take questions in the order in which they were received. Depending on time, we may have to follow up with you post-event with some answers to questions that you submitted, but we're going to try to get to all questions submitted during today's session. Throughout the Virtual Innovation Week, I also encourage you to view the more than 50 innovative tools, materials, applications, and technologies that are on display in our virtual exhibit hall. You can access our virtual exhibit hall by going to our event webpage, www.penndot.gov/innovationsweek. These innovations are being used by federal, state, and local agencies and could help you do your job safer, better, faster, and even save money. There is also a contact form on the virtual exhibit hall page that will allow you to submit any questions you have about a particular innovation. And finally, before I introduce our first speaker for today, please be advised that this session is being recorded. Also, we will be making all recordings of all Virtual Innovation Week sessions available in a week or so on our event website. Further, if you click on the participation link in the calendar invite you received for today's session, you will be able to access a playback of today's session at any time. And with that said, I'd like to introduce our first speaker for today. He is Matt Klauser, who is the Eastern Regional Traffic Management Supervisor in Penndot's District 8. And I'd like to welcome Matt. You now have control.
Hello, everybody. Today we're going to talk a little bit here about utilizing our portable Cctvs. We'll go through some of the uses, costs, and some of the operational benefits and the innovative ways these can be utilized to help operations on a daily basis. To start, we have our portable Cctv specs here. They're roughly 30 feet high. They're solar powered. We get to stream a 1080p HD video stream back to our operations center, and roughly their footprint, whenever we're deploying them, is about a 10x7 rectangle out there is what we're looking for. All right, some of the applications that we have been utilizing our portable TVs or Cctvs are, during key winter locations where we might have an increased crash rate during winter weather conditions, during special events, whether it be the farm show, sports show, anything, where we're going to have atypical traffic and atypical conditions. Areas of safety concern, these can be utilized to monitor and see how particular areas that have a safety issue are operating on a day-to-day basis. We utilize them also throughout our construction projects. Once again, just to maintain situational awareness of new traffic patterns and, lane shifts, anything where we want to just ensure that our traffic management center stays on top of any of the changing conditions out there on our core roadway network. We can also deploy these out to emergency incidents. If we have bridge strikes, bridge fires, major, infrastructure damage to where we would want to maintain situational awareness throughout the event. These can be deployed, within 2 to 3 hours, and we can, have a live video stream of that area. Also, we can utilize it for traffic signal concerns. If we have, either customer complaints or a critical intersection that we'd like to monitor, we can deploy the CCTVs to those traffic signal, to those intersection locations, and look to ensure that it's operating as effectively as we intended. Also, interagency requests, PSP, Secret Service, pretty much any other government agency, if they would like to utilize them, we can help them out to where live data or live video feed would be able to be utilized to increase their situational awareness. So there's just some of the pros and cons of our portable CCTVs compared to their permanent locations. Typically, a permanent location for our CCTVs roughly runs around $110,000. With our portables, the costs come in right around $22,000. So there's it's 20 or a quarter of what the cost of a permanent location does, and it has flexibility on where we can deploy it throughout our district, and it can be set up and running, like I said previously, in 2 to 3 hours from the time that we get a call. We can usually have someone out there move it and gain that situational awareness that we need. Some of the cons of our camera placement issues is finding an appropriate location for the 7x10 footprint of the camera sometimes is an issue. Just finding a nice level spot like that's kind of harder than what you think once you're out there looking at some of the shoulders and some of the locations that we deploy them. Vandalism is a concern as well. People see equipment, and sometimes we haven't had any issues with that yet, but it is just one of the possibilities. And they are integration into 511 for our public feeds. Since the locations are constantly moving, it takes a while to get those up for the public's information. Here's some of the places that we utilized our CCTVs before. Throughout the last year was our US 22322 rock slope project. We monitored the real-time queue that happened whenever we took away a lane on 322 westbound, and then we utilized that information to activate DMSs and kind of relay the accurate information to motorists, and give them a heads up to try to minimize the amount of secondary crashes that we would have. And I just skipped over the slide. I got a little click happy, but another locations that we have used this are the construction of our diverging diamonds throughout. We have 2 different diverging diamonds being constructed in the district, and we've utilized portable cameras at both those locations to, like I said, maintain situational awareness. And whenever you have a pretty complicated lane shifts and construction schedule, it's nice to be able to relay all that information to motorists via our DMS and keep that real-time awareness of those diverging diamonds, and ensure that that they're operating efficiently and we have no operational issues. Some of the District 2 also utilized the portable CCTVs, they actually retrofitted some highway advisory radio trailers. And once again, you know, these came in at roughly $12,000 a piece. They were utilized throughout the Potter Mills construction project up in Seven Mountains. You know, it's pretty big construction, but it provided our central region with real-time information throughout the entirety of, well, it continues the entirety of that project in District 2. All right, and this is something new that's actually came up in, I'd say, the last month since I started making this presentation for this innovation. But we actually started to utilize Microsoft Teams to share videos right back to our TMC operations. We've been in a remote capacity, you know, since March, and we started utilizing Teams. And one of the things that we found we could use is the video feature on Teams. That whenever our District 8 has 2 district incident response units that, you know, respond to high impact incidents throughout the district, and our team can actually use these to show up on scene and relay information as well as share video of the actual, you know, incident scene, so you can get real-time information as your our teams out there. And this is relayed back to our traffic management center, and they really we've only got to utilize it twice so far, but during actual incidents, and it's worked pretty flawlessly both times. One of the things also it can do is kind of minimize or assist with troubleshooting in the field. You know, a lot of times someone may need to call to, you know, have some help troubleshooting our devices. And what this can do is you can stream your video back, have someone else actually take a look at it, you know, look at the different variables that could be affecting the operations, and allow, you know, two sets of eyes be on it, even while the one's sitting, you know, at home in front of his computer. So this is pretty exciting, and we've just started to scratch the surface of utilizing it, but it's something that we're probably going to be expanding on in the future, you know, possibly with some of our county assets. But it's like I said, 2 months ago, we just started utilizing it, and it seems to be working really good. You can see there in the picture, this streams right back into our TMC. So where you have a virtual TMC floor, you can see, you know, the 4 daytime operators there are actually talking right with the field personnel and relaying and seeing exactly what they're seeing out there in the field. So it's pretty exciting. All right, so some of the future uses for our CCTVs, and the next 2 presenters are actually touching on some of this, or maybe not touch on some of this, but their presentations kind of tie into it, in that, you know, with our critical intersection monitoring, as we implement some traffic signal timings, we can utilize our portable CCTVs to, you know, ensure that they're operating as they should, or as intended, you know, as designed. And it'll provide that real-time information streaming right back to our operators that are actually implementing the timing plans, and give them kind of that confirmation that this plan is working. You know, the volume traffic, or the traffic volumes are as expected, and we have a good timing plan there. Looking forward, you know, they may be utilized to get traffic counts and advanced analytics, from, you know, wrong way motorist detection to just your basic, you know, turning movement counts. And that's kind of where we see the future of these portable CCTVs going. Well, that's all I got for my presentation today. You guys have any questions?
Yeah, thank you so much, Matt. We're going to turn it over to Dan. I believe we did get a few questions in. So Dan?
Matt, first question. Could you utilize live video streaming from portable CCTVs or mobile phones in your daily operations?
Yeah, and that's kind of, what we use as TMC really, we're dependent on CCTVs to kind of give us confirmation of incidents, queuing and operations throughout. So we can really utilize this data and the real-time information it gives to kind of verify what we're seeing on, say, Google Maps, on Waze, on our INRIX data, but it gives us that physical kind of verification that this is what's going on and this is actually how operations are moving out there on the highway.
The next question that came in, and this is something I think that's really important in the current work environment that we're in. Could this technology help with remote working environments and minimize resources required to be in the field?
Yeah, like for inspection issues, the team's environment with the video sharing has actually been really it kind of opens up the possibility to where you can have kind of like a virtual field view with only one person being in the field, and so if it's a bridge inspection, pavement inspection, or just something in the field that you want to let people see what you're seeing, and then it can be utilized anywhere where you'd want to minimize that field time and kind of make it more efficient. So prior to our remote working, where one person can now go out and stream all the data back to all relevant parties and kind of collaborate that way. So I think there is some uses for it throughout, whichever agency you're with or whatever your work environment is. I think this could be utilized to minimize some of that field work for people.
Okay, there are no more questions in the queue.
Okay, thank you so much, Matt. As a reminder to our attendees, if you do have any questions for our presenters at any time throughout today's session, please use the chat box on the right-hand side of your screen to enter your questions. So our next speakers for today are Kevin Lewis, who is the Montgomery County Signals Supervisor in Penndot's District 6, and Ted Lucas, who is a signals consultant from KMJ Consulting in District 6. And we'd like to welcome Kevin and Ted. Kevin, you now have control.
Good afternoon. My name is Kevin Lewis. I am the Traffic Signal Supervisor for Montgomery County in Penndot District 6. For my job, I oversee about 1,200 traffic signals. Today, Ted and I are going to be presenting on Unified Command and Control, or UCC for short. It's not working. There we go. So if you aren't familiar with traffic signals in Pennsylvania, the signals are owned and maintained by local municipalities, with Penndot acting as a permitting agency. So there are over 13,500 traffic signals and over 1,150 different signal owners in Pennsylvania. Every traffic signal has a controller cabinet that houses all the equipment needed to make the signal operate. The controller is a computer that runs the intersection. To update the traffic signal timings, you have to update the times that are programmed in the controller. And you can either do that physically by going in the cabinet and entering it, or you can do it remotely if it's connected to the network. So there are multiple manufacturers of controllers, and this is the breakdown of their distribution in PA. The controllers on the street connect to each other and then eventually to a hub or a municipal building. Then this hub or this municipal building connects to the Penndot network, and then it comes back to the traffic management center at the district. This allows remote monitoring and updating. Each brand of controller requires a different software client in order to remotely monitor them. They are not compatible with each other. Many software packages are older and no longer supported by manufacturers. Some of the software is incompatible with current operating systems. This here is a picture of our setup in District 6. Each one of those 4 computers there has a different program with a different username, different password, and different interface. And that is used to monitor the signals for that particular brand. There's also a server for each in the back. To solve this problem, Penndot put out a proposal for a uniform command and control software, with the goal being that we have one software that all the signals are compatible with. The unified command and control that was selected is Untitled Maxview. And now I'm going to turn it over to Ted and let him show you a little bit more about Maxview.
Thanks, Kevin. Good afternoon. My name is Ted Lucas. I'm a consultant at Penndot District 6. In District 6, there are over 1,500 signals connected back to the district office. I've been involved with monitoring traffic signal communications and operations for about 6 years now. And now let's take a look at Maxview. Maxview is a web-based software which has the option to download a local version of Maxview. An advantage of this local version is that it has map layers not available on the web version. Bing Maps with traffic and Penndot Fiber Map overlay are examples of these. The user has the ability to update their local version. They would need to do this when the Maxview server is updated. Maxview is available to all districts in Penndot. 5 districts currently have signals polling in Maxview. Districts 2, 6, 8, 9, and 11, indicated by the triangles to the left of those districts. In total, 500 signals are integrated into Maxview. And now on to District 6. District 6, 4 of the 5 counties have signals polling in Maxview. Philadelphia manages their own signals in their KIT system. Currently, 350 signals are integrated, 75 are polling, with 275 awaiting transition from Centrax, the Econolite software. Econolite controllers can be pulled right into Maxview, and we're working with the townships and municipalities to work with them to get access to the Penndot network and to Maxview to get them polling. The ability to add links is a key feature of Maxview that we really like. In this example, we have the links to the external camera detection shown on the left. These links are directly associated with each intersection. Other links that can be added are camera detection for grid smart cameras, radar for Wavetronics, and also we can add directly to these external links adaptive systems such as Rhythm and SureTrack. Device status, this shows all the intersections currently integrated into Maxview. This is a good way to troubleshoot a corridor. You can drill down to the township or townships that the corridor is in and then filter down to the corridor name. And it gives you an overall look at the status of the intersections, what patterns they're running. And it's a good tool in troubleshooting and a quick overview of what a corridor is doing. split monitor feature. This is a very good feature that we like to use when troubleshooting complaints such as, sat at a intersection for 5 minutes and never got a green light, or it's skipping certain phases. So here you can drill down to a time period, go back in time, and then as it pulls up this data, what you can do here is you're adjusting the time period a little more. But it'll come up with data, and here you in this first tab you can scroll to the left or to the right and quickly look, see if every phase is getting served. So it looks like everything's getting served. Then you can go to the individual split tab, take a look at what individual splits look like, and then the overall average split data. You can look at that, and indeed that phase 5 is being served. Another feature of Maxview is the incident management. Maxview is tied to the OpenTMS software that they use in the District 6 Regional Traffic Management Center. In this, there's a signals module which operators can access. If they need to change timings on a corridor, they can activate action sets that are set up in Maxview and implement a diversion timing if they want to reroute traffic off a major interstate to a arterial. They can change the timings and monitor them in this OpenTMS, and all these changes take effect and are shown in the Maxview software. What we're looking forward to is the integration of ramp meters. We have ramp meters on I-476, commonly referred to as the Blue Route. It runs from I-95 to the Turnpike. There are 14 ramp meters that are scheduled to be updated and integrated into Maxview. To the left is the TransCore software, which is connected to a serial system, and this upgrade getting to Ethernet-based IP will be a nice addition to Maxview. This is scheduled for summer of 2021. Again, looking forward to that. Another feature of Maxview that is nice to have is the automated traffic signal performance measures. Here's showing a split monitor, and we're currently working on getting the detection set up on the intersections that we pulled in, get it configured so we can utilize this report. And now back to Kevin.
Thanks, Ted. So I'm going to go over some of the benefits of the Maxview software. Obviously, there's only one software interface to learn, so people will use it every day and they'll become more efficient at doing their job. For certain corridors, the brand of controller may change from township to township, which the old way meant possibly multiple software for the same road. With the UCC software, you can just do it from one computer. It would also make implementing incident manager plans much easier if the need should arise. Maxview is web-based, and you can access Maxview from any computer with a compatible web browser, so there's no more need for client software. This also means less physical servers will be deployed, and we can align through one central server. The proprietary software required us to purchase license through state projects. The municipalities would also have to have a computer set up in their township buildings to access the systems. The licenses and computers were an added expense on the projects. With UCC, we already negotiated and purchased enough intersections for the next 10 years. So per intersection, the UCC software is much more cost effective. It allows for the projects to be open bid, which allows for competitive pricing. Before, when the controllers were proprietary, they would often have inflated prices. We have special provisions now requiring that the controllers be UCC compatible. And Maxview has also already been successfully deployed in other states, so we get the benefit of having additional features that were requested by other states that were developed. So some of the challenges that we have with Maxview is integrating adaptive signals. Some of the existing systems require their own proprietary software, and then they can't be integrated into Maxview. Integrating existing signals is also a challenge. Someone has to manually set up each signal in Maxview, which requires setting up the lanes, detection, phase assignments, etc. We try to do this with the municipality as they will also be using it, but with COVID, that process has been halted. Some signals currently have incompatible controllers, so they're not able to be brought in the Maxview. And I'm going to turn it back to Ted.
All right, so some of the best practices we had early on, we set a naming convention on these intersections. There's a unique ID for the district, county, and municipalities that are in Penndot districts. Also, for the naming convention for the traffic signal itself, we use the TSAM's ID, as well as including in the naming the signal permit number and the system permit number, which makes it a lot easier to find if you're not familiar with the system or the intersection you're looking for. Another standard was the plan numbering for coordination plans and signal controllers that we use for incident management. We set these ranges aside for, as you can see, any eastbound diversion would be plan 50 to 59. This is coming up with standards makes the system easier to work with, Maxview, and overall a good experience. And some of the lessons learned, the one major lesson we learned was working with signals contractors. I got a call from a signal contractor and he said, I can't add intersections to Maxview. A little troubleshooting showed that it was only admin level users that could add intersections. So the short-term solution is the shell data, the base data for the intersections. We'll add the intersection location and the shell data, and then we'll allow the vendors to edit their intersections. And we hope to have this updated in a future enhancement. Thank you for your time and attention. And as Kevin rolls the credits, are there any questions?
Yes, thank you very much, Kevin and Ted. We're going to shoot it over to Dan for any questions that have come in.
Kevin and Ted, the first question that came in, what other controllers can be integrated into Maxview?
At this point, so that Maxview has their own controller, or Intellite has their own controller, we can use that, and the Econolite controllers transfer right in. Siemens is real close getting their MIBs worked out with Intellite, and I believe the next step is for the NASTech and the Kane controllers. They still are working on that, so they're not there yet. So Siemens would be the next one.
The next question, how many Maxview licenses has Penndot obtained?
At this point, my understanding is there's 10,000 licenses that were purchased with this software.
Next question, what will be the cost to a municipality per intersection after the 10 years are expired?
I don't know. Do you know that, Kevin?
I don't think, I think it's just a one-time license, maybe. I'm not entirely sure about that. I think once they're added in, it's just ongoing. I think we just buy it up front.
Okay, and then the last question I have right now in the queue, what type of training is planned?
The plan is to get some video trainings for users and have them accessible on the Penndot network. At this point, I don't think any of that has started, but there is a plan to do some sort of video training.
I actually have a question for Kevin and Ted. You talked a little bit with regard to Maxview and other states' use of Maxview. Can you expand a little bit from your research in terms of other states' use and some lessons they're learning, challenges they're facing, best practices, and some benefits?
I don't know if we have any direct feedback from them. I know central office was very involved when they did the bidding process. I know they talked heavily with these other states. Like I know, I'm pretty sure Georgia was one of them. I can't recall the other ones, but there are multiple states, and they were consulted. Utah used it as well, but they were consulted during the proposal process.
All right, we got another one in on the chat pod. Are municipalities able to use the program to modify timings? And if so, are they approved by the department?
I'll answer the first part of that. Through Maxview, it depends on the rights that they would have, but I would imagine they would have rights to change it, but I believe everything has to be approved by Penndot before any changes are made.
Yeah, they should go through their county signals person to, I'm not sure how other districts do it, but they should get whatever's on, they need to get a permit revision if they want to change timings. So they should be submitting to Penndot before making changes.
And we'll keep the questions going. We just got another one in on the chat pod. Existing intersections with incompatible controllers, will they be still visible to Penndot until updated or replaced? And any concern for lost connectivity until update or replacement?
So depending on what type of controller, so like we have the Peak system, Peak is not compatible with Maxview, so we'll just continue to monitor those intersections in IQ Central, the Peak software. There's some older controllers like dial-ups. I think the next step is, we would still have that in that software, but the next step would be to upgrade those to Ethernet controllers to get them into Maxview. So it's a process, but we would not lose. If it's in a Peak system or NASTech, it's staying in that system for the time being.
Yeah, to add on to that, just because if these carders have multiple controllers in a system, we wouldn't just do one at a time, because then you would break the system. So you would do like a carder-wide upgrade all at once and replace all the controllers at the same time.
Okay, I think that's all the questions we have at this point. Again, if you have any questions for Kevin or Ted or any of our other presenters, please enter them in the chat pod on the right-hand side of your screen. With that said, we're going to move on to our next presenter. Our next presenter is Brian Crossley, who is the Temporary Traffic Control Unit Manager in the Highway Safety and Operations Division under Penndot's Bureau of Maintenance and Operations. So I would like to welcome Brian to today's session. Hi, Brian, you now have control.
Thank you, Danielle, and good afternoon, everybody. So this afternoon, I'm going to take a few minutes to kind of go over smarter work zones with everybody. Last year, I had given a presentation as part of Innovations Day that focused more on a particular strategy for smarter work zones. I thought, being that we're in a virtual setting and the Innovations Day was kind of opened up to more participants, while some folks may have, had experience in deployment or managing a smart work zone on a project, there may be some people, as part of this group that may know the term, may have heard of it, but really doesn't understand what a smart work zone is. So for that purpose, I tailored this presentation to be kind of more of a definition or a defined approach to what smart work zones are. So basically, a smart work zone is the deployment or inclusion of a strategy or several strategies that essentially enhance the safety of the work zone for the road users and the workers. It also enhances the management of how that work zone functions when it's being deployed out in the field. And it also, enhances the effectiveness of mobility, which is very important because on a work zone, if you start to lose mobility because of congestion and queuing begins to develop, and those speeds come to kind of a seizing halt, the travel speeds through the work zone, you've really kind of increased the risks that are out there, which essentially kind of throws the whole safety principle. It's certainly for the motorists, but also for the workers as well, because if this happens within the pattern itself, you could essentially find motorists trying to avoid a rear end collision, and they may enter the work zone, thus putting the workers at risk. So a smart work zone essentially is to try to help minimize at least, or hopefully eliminate any potential hazards or additional hazards that are already out there as far as working out along a public highway, whether it's construction or maintenance. So with that, I'm going to go over 5 particular strategies that are under the definition or the umbrella of a smart work zone. You see them here on the screen, the 5 that I plan on talking about. There are more than 5, but these are kind of what I look at as the 5 principal strategies that can be deployed to make a work zone smarter. So the first one I want to talk about is speed management. Now, I think everybody is familiar with what are called speed feedback signs. Other names that are commonly used with these are speed display signs, radar speed monitoring units, speed minders, and there may be several other names, but essentially it's what's on the lower left photo there, which has whatever the existing speed limit is in that area through a regulatory sign posted, and alongside of it is a digital feedback that's tied to a radar unit that tells the motorist, what speed they're traveling, so they could gauge it against what the actual posted speed limit is. Other speed management principles or deployment opportunities. Everyone should be aware at this point that Pennsylvania does have an automated work zone speed enforcement program. This has been the first season where we've deployed it in our construction and maintenance activities. It is a very good program that we're very proud of, that we are seeing numbers that it is helping to enhance the safety of the work zone, as we are seeing more conformance to travel speeds out on the roadway. There's been, since this program began, since deployments began earlier this year, we are seeing those numbers where speeds are starting to drop overall, not only in specifically the work zones that they are in, but we move these around for a purpose that people don't get accustomed and don't think that they're not in a particular work zone, or only expect to see them in a particular work zone, but they never know where they might be, other than, we do give information through the website as far as help to help encourage safer travel speeds through all work zones across the Commonwealth. And then the other thing I have here is variable speed limit signs. Now, this is something that's relatively new in Pennsylvania. The Interstate 83 project, the Capital Beltway project in Harrisburg, has been utilizing them. But essentially what they are is it could be either through an algorithm that runs the program, or you could program the devices that, based on certain times of the day, that a particular speed will be posted. And it's the intent of that is to post a realistic speed based on the amount of traffic that is traveling. Because when you get in these urbanized areas where you have higher traffic volumes, certain times of the day, as traffic volumes increase and congestion begins to build, speeds tend to start slowing down. So these signs can react to that and post a more realistic speed, so that there's more conformity in effect to help continue the mobility, so we don't continue to increase congestion at one point while higher speed traffic is moving up behind them, and then they're surprised, and you have that risk of a rear end collision. But if we can tell them ahead of time that speeds are slowing, they could begin to start stepping down to be more in conformance of what's happening out on the roadway. And then obviously, there's opportunities there that during work times, when workers are out there, maybe it's more realistic to have a lower speed limit during those work times. But then when work is not in active progress, say it's the weekend, say it's nighttime or whatever it may be, when the workforce has gone home and it's just simply, traffic flowing through the work zone, you want to get traffic flowing through there as efficiently as possible, then that reduced speed limit may not be necessary, and it can adjust and go back to an existing posted speed limit. Now, all of this is well and good, and they're great tools, but they're only going to be as effective as what the posting of the speed is out there. Whenever possible, we always want to try to design our work zones to the existing posted speed limit. However, there are times when it is necessary to do a speed reduction. But when we're doing a reduction, it needs to be somewhat realistic, so these programs or these strategies can work effectively and efficiently. And it really kind of conforms to not only the speed limit policy that we released earlier this year, but also it conforms to Federal Highways Manual and Uniform Traffic Control Devices that states that speed zone reduction should be avoided as much as practical, because particularly motorists are only going to reduce their speed if they absolutely perceive the need to do so. The next strategy that I would like to discuss, and Danielle, I'm not being able to advance my slide here. Oh, there we go. Traveler information. So traveler information essentially is a deployment of devices that tells the road users what to expect as they are either approaching or traveling through a work zone. Now, last year during Innovations Day, I spoke about the travel times in work zones, and particularly about a project that was deployed out in District 2 on North Atherton Street, where message boards were utilized to tell the motorists what they could expect from entering the work zone and how long it would take to get to a specific point within the work zone or beyond the work zone. And that's essentially what a travel time scenario would be, or travel time information would be for a road user. We see them obviously all the time when there's not work happening, as the TSMO people under Ryan Mcnary supervision, they already do this under normal circumstances. If you're traveling down through, say, the Interstate 80 corridor, they give the focal point, or they give a destination point to the road users and tell them essentially how long they can expect it's going to take them until they get to that point. Well, we can do that in work zones now too. And what had happened on this particular project was they retrofitted the contractor's message boards with a modem and some other hardware and software programs that connected to their ATMS software that was being utilized in the TMC, and they can monitor that. And the same thing with queue warning systems. Queue warning systems really are not a new strategy. They've been out there for quite a while. A lot of people have been hesitant to use them, even though they are value added. They've been hesitant because of the cost. When these strategies initially came out several years ago, you could be looking at $100,000 just to deploy a queue warning system on a project. And that included the message boards. That included, at that point, sensors that were placed out on key strategic areas along the corridor leading up to the work zone, that as travel speeds began to slow down and congestion began to develop, it would trip the sensors to communicate to the message boards that either slow traffic was ahead or stop traffic was ahead, and the road users need to be prepared to stop. But through the partnerships that we have with folks like Waze, like INREX, like Google, and all those types of data sources, and the agreements we have and the contracts and those partnerships, we can effectively be collecting that data in real time and be communicating through the ATMS platforms to get the word out to message boards. Obviously, we can easily do that with our semi-permanent and permanent message boards and CMSs that are out there. But even so, we're working towards being able to communicate with contractor message boards or even maintenance force message boards that are in the stockpiles as they're being deployed, to try to communicate that information out to the work site and to the road users approaching the work zone. Danielle, please advance. Exposure reduction. So anyone working out on their roadways, obviously they want to be safe, and they certainly want to feel safe while they're out there. In a realistic or an ideal situation, positive protection is always the best scenario to protect workers from incoming or oncoming traffic in the event there is an intrusion in the work zone. Unfortunately, some work scenarios, some work activities aren't really conducive to be setting barrier out, because maybe it's just simply doing a crack sealing job, doing a small bridge patch or a pavement patch on the roadway, or you're on a corridor that you can only close a lane maybe during nighttime hours, but it has to be open the very next morning because traffic volumes just don't allow a long-term lane closure. There are options out there that we can be deploying that will reduce the exposure to workers to oncoming traffic, and still allow that mobility to happen. Up on the top right photo there is a photo of what's a movable barrier system. On a permanent situation, movable barrier systems have been deployed out on the Ben Franklin Bridge as well as the Walt Whitman Bridge in the Philadelphia region. So if you're familiar with that area, certainly you're familiar with how they manage their travel lanes during peak volume times at certain points of the day, and when they know they need to switch the number of lanes going inbound versus outbound. But this type of deployment can also be utilized in work zones. The state of Indiana has been utilizing these on some projects, as well as some other state DOTs with great success. This is a strategy that we've been looking hard at trying to get deployed in Pennsylvania. With anything, initially getting something like this deployed, costs tend to be higher on the onset until you get it in here and get more people to buy into it. And then those costs come down and it gets to be a little bit more palatable for districts to deploy on their work zones. Several districts have expressed interest in trying to move into this, and I think you're going to see this as time moves on, that we will see more deployments of movable barrier systems in Pennsylvania, which will help effectively manage traffic at peak volume times while providing safety during times when workers are present. Down below that is a mobile barrier, which is essentially a tractor trailer that is pulled behind a tractor, and essentially it creates a temporary barrier that workers can work behind during the course of a day or a shift when they're doing maybe some minor pothole repairs or patching repairs on a bridge, or even guide rail hits out along the freeways or expressways. The department does own one of these. The department purchased one of these last winter. It is overseen and managed by our fleet division. COVID kind of hindered the use of this year, but we do anticipate this will be getting out to our maintenance forces, and we will, allow county maintenance forces the opportunity to utilize this and to kind of pilot this, to see the effectiveness and the efficiency and the benefits of having this available, and help make those decisions down the road if more need to be incorporated in our fleet. And then the last thing I'll talk about as far as exposure reduction is autonomous truck mounted attenuators, also known as ATMAs. Many of you probably have heard of these. Several states have already deployed these, one being Colorado, Missouri, and I believe even Minnesota may be in the market of deploying these now. We are also very interested in deploying these. Our law allows us to use these, and essentially what they are, it's a driverless truck that follows, in this case, it's following a paint truck. It doesn't have to be a paint truck, but I know Colorado DOT through a peer exchange, that's exclusively what they are using their ATMA for, is as a supply vehicle that follows the paint truck as they're out on the freeway doing pavement markings, their maintenance work on their pavement markings on an annual basis. See, the whole benefit of having an ATMA as part of say a paint train or any other mobile application is, like many other states, Pennsylvania has seen an increase in truck mounted attenuators being hit out on the work sites. Of any work zone intrusion or collision that is really prevalent right now, has been one of our highest damages as far as equipment and potential injuries, as our shadow vehicles are really suffering, not only on Pennsylvania or Penndot owned highways, but particularly the Turnpike has seen a lot of it themselves. So taking that driver out of that shadow vehicle really kind of enhances that we're not going to have an injury out there when a work zone intrusion happens. So we're excited to get this to fruition and make this a reality, and we'll be working on trying to do that here very, very soon. Next, please, Danielle. And then managing traffic and performance. So a couple of these principles aren't necessarily new. The late merge, which utilizes the sign that says use both lanes to merge point. We talked about a little bit of this last year during Innovations Day. There are a couple of districts that are deploying this principle on multi-lane roadways that have a high number of congestion and slower traffic, and they're trying to minimize the length of a queue that develops leading into the work zone. So encouraging road users to use both lanes really kind of encourages that reduced length in a queue, and it works well in your kind of your suburban and your urbanized areas. It may not be the best practice on a rural setting. That doesn't mean you can't maybe experiment with it and try it, but experience typically shows that this type of a work zone doesn't necessarily work well in a rural setting. But the dynamic lane merge, basically what that is taking the hybrid of the late merge concept and marrying it to a standard work zone where you're just doing a traditional lane closure. And how that works is, rather than static signs, it is utilizing message boards. And it is basically similar to what I talked about earlier with the traveler information and the queue warning systems, is that taking either data feeds or using sensors along the roadway, it starts to detect traffic behavior, and it adjusts the type of lane merge it needs to be based on that. So if congestion is beginning to build, it could sense that it needs to go from the standard lane merge signing and change it to a late merge signing, so it can better manage the congestion, the queuing coming into the work zone. Sequential merge lighting. And I'm not sure, Daniel, if you can turn that video on real quick. Again, not entirely new, but not a lot of areas are utilizing this yet. However, when we release 213, we're expecting that for long-term lane closures, we're going to want these deployed out on our merge points. And essentially, it runs like an airport runway where it's guiding the road users from one lane to the other and helping encourage that merge movement much sooner as they're approaching during nighttime or inclement weather hours. The last thing I'll hit on the managing traffic and performance is the ramp metering. District 11 a few years back utilized a ramp metering scenario or strategy as part of their work zone on a project on Interstate 279, which essentially helped to manage, when road users need or could enter the work zone on the main line from an entrance ramp. And the intent was because of anticipated congestion on the ramp and it backing up through the corridor, and or knowing that there's a lot of traffic on the main line. Through sensors deployed upstream, it detects when there's a gap big enough that a road user sitting at the ramp at what they used as a portable signal would change that indication from red to green, and then they could, or to yellow, and they could, advance into the work zone and be on their way. That's been the only deployment thus far, to my knowledge, in Pennsylvania, and the feedback was very positive that it worked very well. And there's been some interest with some groups with Federal Highway and putting a report together, in which are working with myself and contacts out in District 11 to kind of give some lessons learned and some suggestions and recommendations moving forward on how other state DOTs could deploy this strategy as part of their work zones. Next slide, please. And then lastly, I'm going to talk about is just performance monitoring. I talked a little bit about this last year, but we have several traffic or transportation management centers across the Commonwealth that monitor how traffic is behaving on our core roadway network, and work zones is no exception to that. The folks that work in these centers are very interested in how well work zones are behaving. So with the partnerships that I mentioned before, through Waze, NREX, Google, and anybody else that we have partnerships with, they can take that data feed and kind of help monitor how work zones are performing. It also helps in the decision making moving forward on maybe when the best times are to allow a lane restriction on a roadway or not allow a lane restriction on a highway. As we take that data feed, COVID, changed things earlier in the spring of this year. Now, not to take away from maybe what Ryan may be talking about next, but I'm sure he's got some information potentially regarding that, how traffic has rebounded since then. But having these traffic management centers and monitoring can kind of help enhance the performance of a work zone through these data feeds. And obviously we're pushing information out. These fine folks are taking the entries that come in through our CRS request right now via telephone. However, we would like to move that to a mobile situation down the road where things can be just, pre-populated, and then field people can essentially activate and deactivate that event in real time out in the field through smart tablets and iPhones and whatnot. But for the time being, the way things are held now is through phone calls, and then they're entered, and then this information is pushed out, to 511, which also talks to Waze. So people are getting alerts on their phone as they're traveling, down a core roadway network, and they're approaching a work zone. They're going to get that notification that there's a work zone ahead. So it helps them to plan their travels better. And if they're getting on the apps prior to leaving their departure point, they can effectively make better decisions on whether they should maintain the course they plan on a certain roadway, or if they should diverge and take another route to avoid any type of conflicts or congestion. So That's all I have for right now. So with that, I'm going to give control back over to Danielle and answer any questions.
Thank you so much, Brian. We do have a few questions that came in, so I'm going to kick it over to Dan to ask those questions.
Brian, first question. Merging lanes through a construction zone is always an issue. Motorists seem to create traffic jams, not knowing how to utilize the open lanes and when to properly merge. What can be done to improve the merging conditions of traffic through a construction zone?
So I talked about some potential strategies with either the late merge or the dynamic merge. And again, every tool may have their place in time along a roadway, but they're not necessarily a fix-all for every scenario out there. So unfortunately, in that regards, each area needs to kind of know their roadway network and what works best and what doesn't. Getting advance notice out there with signing, if it's desired to get motorists over sooner, is ideal. When I said about contact, right now, when roadwork is entered through RCRS, those calls are coming in to the TMC for notification. Through that opportunity, if available, they could also communicate to any permanent or semi-permanent CMS board that may be out there upstream. Whether it be 5-6 miles down the road, they could communicate to the oncoming traffic that there's roadwork ahead, right lane closed, or left lane closed, and they could start to prepare for that movement as they're advancing to the work zone. Nighttime lane closures, again, sequential lights can be very beneficial in that. Maybe even incorporating additional arrow boards if you're seeing an issue, maybe another way to kind of help enhance merging as traffic is approaching the work zone.
Brian, has anyone utilized the movable barrier system on a Penndot project?
So far, as far as on a work zone project, no. Like I said before, there is permanent applications on 2 of the major river crossings in the Philadelphia area. However, we have had a lot of interest from several districts, and we have one of our central districts that has a project that is in final design that will be deploying this in the next, probably within the next 2 construction seasons. There's potential that it should be out there. So we're kind of excited for that. I'd really like to get some more projects to buy in on this, but as of right now, no one's used it, but to my knowledge, we have a district that will be using it.
Okay, we just got another question in on the chat pod. Is Waze and INRIX data coming in being evaluated by the TMC operator to make a decision on how to react? Or is there software assistance to help decipher or understand the real-time data coming in?
So I think they're looking at it real time. I might suggest, since the TMCs aren't under my umbrella, they're more under Ryan Mcnary. That may be a good question to say for him, since he's our last speaker. But to my knowledge right now, I know they've been working on different software platforms to enhance and to better our TISMO operations. But and I'm happy to join in the conversation after he's done presenting, but I'm going to defer the bulk of that answer back to him.
Okay, and the next one we got, has the department seen increased conformance to posted speed limits when utilizing any of the speed management strategies?
Yes. Yeah, we do see better conformance when, especially with, once automated speed enforcement's been out there, travel speeds do get more in line with what is posted out on the roadway. And when you're posting speed limits, when workers are out there and you have a lower posted speed limit, travel people tend to slow down when they see bodies out on the roadway. They're a little more cautious, as opposed to when they're going through there on a Sunday afternoon and nobody's out there. Their travel speeds tend to creep up more to what they feel is more realistic for their condition. So it's a long-winded answer, but yeah, we are seeing more conformance to posted speed limits.
Okay, and the last one we have, do you have any success stories to share related to the deployment of a smart work zone strategy?
Well, like the ramp metering system that was deployed out in District 11, we got good feedback from their work zone manager at the time that the information she was getting back from her field people at the time that it was working very well. I've heard good feedback from several districts that have used queue detection systems that, when congestion begins to build and those message boards change to, slow traffic ahead or stop traffic ahead, those message boards are swapping out like they should. Unfortunately, people are still getting caught in congestion. And we're trying to do better at managing those situations, but at least when queue warning systems are out there, they are getting the information we want them, conveyed to the approaching motorist. And then, like I've mentioned already, I'll mention again, the automated speed enforcement seems to be doing very well in its first year. We're very excited about that. I'd love to say that, we've had a success story with the the autonomous truck mounted attenuator. We just simply don't have one and haven't used it yet, but I can tell you, based on the peer-to-peer exchange we have with Colorado DOT, they are very happy with how it's going out there, and they're actually looking to expand their program. So I would consider that a success story, even though it wasn't Pennsylvania based, but it will eventually make its way to Pennsylvania, and I don't see any reason why it would be any different here.
Thank you so much, Brian. And actually, I'm going to pose that last question to our audience members. If anyone has a success story to share related to the deployment of a smart work zone strategy, please type that into the chat pod after our next presenter, provided we have some time. We'd love to hear from our audience members if they have a success story that they'd like to share with everyone participating today. So thanks again, Brian, for a great presentation and great discussion here. So our last presenter for today's session is Ryan Mcnary, who is the Traffic Systems and Performance Manager in the Highway Safety and Traffic Operations Division under PennDOT's Bureau of Maintenance and Operations, excuse me. So I'd like to welcome Ryan to today's session. And Ryan, you now have control.
There we go. Good afternoon, everyone. Where did it go? There it is. So that was a great setup to what I'm going to talk about. So Brian talked about a bunch of stuff. I'm just going to use the arrows. That is relevant to what I'm going to discuss. So basically, what my office oversees is the traffic systems that our traffic management centers utilize in the 24/7 operations, then also all the data that comes along with it. So we take the motto or kind of goal to make sure that we understand the data so we can potentially improve operations going forward. By improving our operations, hopefully that impacts the safety for the public and the motorists out there. So what you're going to see in the kind of the preface of this conversation is I'm going to be going over some data with you. So keep in mind there is going to be some information here. I'll keep it as high level as possible, not to lose anybody. But the concept for this is I'm going to go over the data and then I'm going to go over the strategy or solution that we implemented. So there's 4 key areas that we looked into. So one of the questions that came in from the audience right now was about crowdsource incident identification and whether that's being used in the TMCs. I'm going to be going over that first. Then we're going to be going over kind of what Brian alluded to with the queue protection messaging, smart work zones, and kind of what we're doing with the advanced transportation management system and potentially making that available throughout the state. using probe data, where you don't have to deploy detectors. We are one of the first states in the nation that has their own Pennsylvania-specific congestion pie chart. We've already started to look into deploying that for planning and ITS deployments and things along those lines, and we'd like to make that available down on the municipality level. But then I'm going to relate some things that are really relevant to everybody right now, and some of the things that we learned from the department perspective, operational perspective, from the downturn in traffic volumes and the impact study, so relative to operations. Let me make sure that works. There we go. So as I'm setting this up, so keep in mind all the information and all the data that you're going to see is specific to the blue routes on the map. So we considered that our core roadway network, and I think you heard Matt say that in the first presentation. But those are all the routes on 511. So if you went to 511pa.com right now, you would call in and you could potentially get a traffic report. These are the same routes. So it's your major interstates, your major arterials throughout the state. So it's roughly 4,000 miles, 10% of what Penndot owns and operates. So Penndot owns and operates roughly 40,000 miles in the state. So that's a little preface that all the data you're going to see takes place on these core routes. So going forward, our data program, the TSMO Performance Program, has approximately 40 terabytes of data that have been correlated to different crowdsourced data sources like Waze and INRIX. We use Power BI, it's a Microsoft product, but we have our crash records, so those are police reports. We have our incident management system, which is the road condition reporting system, our RWIS stations, so the weather out there, I think there's roughly around 40 or 50 throughout the state. Our maintenance database to understand where Penndot teams are out there, our traffic counter, way in motion, permanent sites and some temporary sites as well. And then we have our ATMS DMS message history. Now this is all linked locationally, so we can tell where incidents per se are happening via Waze, and then where there's slowdowns with the speed data from INRIX. And then we can understand getting back to the crashes and then the conditions on the roadway at the same time. So that's a little background, but we started this process of the TSMO Performance Program of understanding crowdsource incidents. Is Waze good data? You know, there's a lot of people out there that just simply say there's a crash right here. Well, let's validate that. So what we did is we linked it to our crash database, and it came out to the conclusion around 87% of INRIX and Waze combined to detect reportable crashes. So little background: a reportable crash in Penndot or Pennsylvania is a crash where an individual needed to either be transported from the scene, so they were injured, had to be taken in an ambulance, or the car had to be towed. So that is what is deemed a reportable crash. So that is not your fender benders or the police just showing up, for example, to write a report. Official crash report submitted is for those two scenarios that come into our office. So there's still, you know, several. I think it's like 200,000. Don't quote me on that. I can't remember. It's been a little while since I worked in safety, how many crashes there are. But what we looked at here is to understand who was the first to detect. So INRIX focuses on speed data. So they obviously understand when there's an impact on the roadway, a reportable crash, someone was injured, or it's going to take capacity. So they predominantly found these crashes 50% of the time first. Waze around 27%, and then our traditional methods, traditional meaning our TMCs, so our traffic management centers, received a phone call from either state police, they heard it through the radio, they saw it in a computer-aided dispatch feed, etc. So, or they picked it up on their own, you know, via these other sources before anything else was reported in INRIX and Waze. So on average, this is statewide, 7 minutes it took for INRIX to find it, Waze around 9 minutes, and then our traditional methods were around 13. So this evolved that this was a good data source. So what we ended up doing, and this isn't a new concept, the Pennsylvania Turnpike has this as well. It's not exactly this version, but they have their own. We developed an internal crowdsource instant application. So it takes the concept of almost like a news feed. So where operators get this in real time via the data feeds that my office manages from Waze and INRIX to understand where the crashes are happening or the incidents and the slowdowns, for example, throughout that core railway network I told you about. Now, if you look at the red boxes on the left, you see the source, Waze, INRIX, and then you see there is RCRS in there too. Now, that's the Penndot incident management system. What that allows our operators to understand is, okay, they have an incident. They have now verified that incident. They've entered it into their incident management system. And then on the back end in our databases, it is correlated. So now they know that they're working that, or anybody knows that they're working that incident. We have traffic operations responses in play. So moving over to the right, I guess it would be the middle. You see congestion, reported time. So congestion is the length of congestion that is being experienced or reported via INRIX. Now, keep in mind, I did say INRIX is speed data. So that is the amount of consecutive segments of roadway that are experiencing slowed conditions beyond the historical norm. Okay. Now, I know that's a loaded question, but we can keep it at that level. We don't need to go into it any further. Reported time is the most recent, would be the first time it was reported, but key in on that status. So it's active, that not so much, but look at the V40 or V34, for example. That is the amount of versions that Waze or INRIX has submitted to us via their data feed. Now, each one of those consists of a timestamp. One thing when it comes to traffic incident management that's always been important to us is understanding the incident timeline. So looking in the right-hand corner, we have an incident timeline now, and one thing we're kind of proud of that allows us operationally to make decisions or understand if our operations decisions are making a difference out there is a real-time incident timeline. We have the ability via those timestamps and everything we're getting via the data feeds to understand where the H and the T, if you see on the map there, there's blue little arrows, H38, T38, the head and the tail of the congestion are. Now, as you would scroll through the 1 through 40 of the versions at the top, it offers you a look back in time of where those heads and the tail and the congestion is. Why that's powerful is we're constantly getting information from the field, whether it's PSP, whether it's our Penndot maintenance teams out there, for example, or whether, it's a tow truck driver or our service patrol. They're constantly telling us the scenario, the situational awareness of what's going on in the field. Also, keep in mind, our actual congestion ends may go past certain areas where we need to divert traffic around different detours, or we have other solutions like DMS that we should probably put more congestion or queue protection messaging on from the TMC operations perspective. So it gives us a look back to understand the impact there, and then the bottom box is really an overview of everything that was in the former slide that I showed you. So we are looking to hopefully make this available to people outside of Penndot. Now we have to do some modifications to the system. We've had some requests from the Pittsburgh region. Some municipalities in the Pittsburgh region were interested in this. We have to look at our licensing a little bit to understand if it's something we can share, but I don't think we're going to see too many concerns there. But let us know if that's something you would be interested in having, because I know there are local traffic management centers that do have this as well that aren't Penndot related. Moving on, so we're gonna go into queue protection, and we're gonna focus on two case studies that we talked about. I'm not going to get into one a lot because Brian did a great job of introducing smart work zones. So I'm just going to show you what we found out at looking into this and kind of just the decision making we can use going forward with maybe deploying certain boards or helping with our traffic control plans. But I'll get into that a little bit. So this one focuses on secondary crashes, and I'm going to talk about a solution that's very new to Penndot that we're developing right now. So we took a different methodology for secondary crashes. So primarily when people think of secondary crashes, they think of it's a police crash report, the police officer checked the box. What we did here is, since we have that speed data, we know where that first crash was, reportable crash. We also have the availability of looking back behind it, upstream is like what we call it, to understand how far back in that queue or how long after that initial crash did a second crash occur where there was congestion. So these are those dangerous crashes. I mean, I know how many times I've been sitting out there and I'm sitting at the back of the queue, and I'm on the highway and I'm over top of a hill and I'm just cringing at what truck could be coming over, and I hope they can see me. And, you know, a lot of people put their four-ways on, and I don't blame you. So these are very dangerous. They're overrepresented in fatalities and injuries by percentage. So you can see that the numbers of the severity there, but the minutes, so 81% occur 15 minutes after the crash. But what was alarming to us is we have that primary crash, those queues growing for a long period of time. 46% of those secondary crashes happen an hour after that initial crash, and then over 2 miles back from the initial crash. So there were queues and there were congestion 2 miles and upwards, sometimes over 5 miles. And why that's important, you put it into perspective, like I alluded to, is the hills, the sight distances, the curves, and things along those lines, where we need to understand what our roads were like out there. So we're working on some data sets on that, but that is one thing we're looking. We investigated for secondary crashes. Now, this is not directly related to a solution that is more tangible with the brick and mortar infrastructure, but this is a virtual solution that we'd like to consider going forward. And we're having this developed by our 511 PA vendor right now. So highway advisory radios, they're the beacons that you see flashing. We call them wigwags that say tune to 5:80 a.m. For an urgent Penndot alert. Sometimes they don't work very well. Sometimes you can't hear them, and you can only hear them for about a mile. But it's a great use case. It offers our operators in our TMCs the ability to write a message, and then it gets converted from text to voice, and people can hear it out there over their AM radio. And it's one of the only things that we're not limited to characters as so severely as we are on our dynamic message boards. So what we came up with, and to try to facilitate that use case, was, okay, we have this ability, we have this call-in 511 system. Why don't we link the 511 system, the app, the website, the call-in aspect, to kind of replicate what HARs were intended to do? So we worked on this. We kind of pitched the idea to our team. So 511 is managed between our office and the Pennsylvania Turnpike. So we pitched the idea that we kind of came up with, and the Turnpike agreed that it was, you know, something that they would like to have for them as well. So this is something as we're developing in a cooperation here. But going down the hierarchy on the right, so an operator would write that message in. It would then be populated over to the map. For example, on the website, you can see in the bottom left-hand corner where that radius, an individual that went to the website could click on it, and it would read off the HAR message to them. It would show the radius, for example, or an individual driving, and they see that they would like to, they see there's an urgent message or the beacons are flashing and it says call 511. It would then become we call it a floodgate, a priority floodgate, which would come to them first and explain to the motorist what the operator is seeing. There is the Interstate 80 is closed at mile marker, etc. You know, however, whatever the message they would want to do, it would be read off to them. But here in Pennsylvania, we have an award-winning 501 PA app, if you didn't know that. You can actually have a routing methodology and an application that's in there right now. So it can be overlaid with Google Maps. It can also be overlaid with Waze. So you go into the 501 PA app, you type in your location and where you want to go, and it will route you through Google Maps, but it will offer the 511 alerts that you sign up for. And so if you would want to receive HAR messages as you would drive through that area where there's a geofenced HAR message that you would receive from an operator in a traffic management center 24/7, you would have the ability to do that. You can opt out, of course, but that is something that we're working on too. And then kind of the worst case scenario, major road closures. We know it's going to be closed. There's a bridge on fire, for example. We need to keep people out of this area. We have the ability to send push notifications to anybody that has the app downloaded. So we run into these, believe it or not, we run into these crazy scenarios a lot in the operations world. When I tell people we have sometimes 4 or 5 roads closed, interstates throughout a typical day, that's shocking to a lot of the public, but that occurs throughout the state from the statewide perspective. Multiple major interstates closures, and for sometimes several hours at a time. Now, geofence push notifications would have to be approved by our statewide traffic management center, as it would be alerted and escalated up from the districts. It's just a checks and balance measure. We don't want to be having too much intrusion to anybody that has the app downloaded. So that's one innovative thing that we're working on right now. So moving on to work zones, and Brian, like I said, hit this really well. But here's some of the data behind Brian's concepts. And I'll just talk about it a little differently because this one uses probe data. So 924 work zone congestion related crashes. So queues start to build, there's congestions around the work zone. There's restrictions, there's barriers on either side of you. It's overrepresented for injuries and fatalities for the types and the percentage of the crashes. So if you're looking down at the graphic below, not surprisingly, we found in that first half mile, when that congestion starts to build in that work zone, it is the most dangerous. So 52% from the start of the work zone, as soon as people start to slow down, whether it's panic or it is a complete stop, that is the primarily amount of the time. But again, 32% 2 to 5 or more miles back as of queues. So where this gives us the information to potentially consider where we deploy our portable message boards. Now keep in mind the portable boards need to have connectivity to work with this. So they would have to have a modem or they have to be connected to the Penndot network. But these messages are actually taken from the I-76 project. So they were designed for that. And they're going to be deployed here hopefully this winter on some projects. We are piloting this on I-78 this winter as well, and potentially on I-83 coming up I-83 north from the York area. So keeping with the congestion theme and talking about planning now, the congestion pie chart. So I put this example up here, but it's more of an urban example. You have the whole Pennsylvania pie chart down to Philly, and then the corridor level. We have the capability to run this to the corridor level. We're looking to have municipality added here too. We'd like to be able to run a congestion pie chart by municipality or a census tract, for example, just to offer some a little more granularity for our partners out there. But like I said, we're one of the first in the nation to do this. There's a lot of people that have been trying to do this for around 15 years. But one thing that really helped us was that our correlation to that crowdsource incident data. We had approximately 20 to 25% unknowns before we brought in Waze and INRIX and different incident APIs. So we know from the Penndot perspective, we don't get all of the incidents that impact our road. But by the grouping of this other information, it gives us the ability to learn what these causes of our congestion is on our roads. That is immense when it comes to planning, because what are we always trying to reduce? We're trying to reduce people sitting in queues, wearing down roads, having traffic. We want people to move from their point to their destination, their starting point to their destination effectively, whether it's commerce or public in general. So we realize, a lot of them are self-inflicted road work, but it has to happen from time to time. But this gives us the ability to scale it down. And if you notice one thing that keys out, if you look at the green, recurring congestion. So recurring congestion is what you would experience probably pre-COVID. I think so. It's coming back in some of our more urban areas. That AM peak when everybody's driving to work, or that PM peak where everybody's driving home, where everybody would sit around 4 or 5 o'clock. So you can see on I-95 in Philly, 44%. I know I've sat in that traffic before. But this started to be used in our regional traffic operations to plans for ITS deployments of more boards, DMS boards, etc. So this is kind of a really high level congestion source definition. I'm not going to get into this too much with you, but we do have rubbernecking on there. That is something that is kind of new. A lot of people always ask questions about that. So real high level, we have an incident on one side of the road, but we have a slowdown on the opposite side of the road, but we could not correlate any of our other incidents to that side of the road. Another question that people always ask about, how do you determine what is recurring congestion? So that is a speed drop that is not more than 10% greater than the historical average drop for that day or time of week. So keep in mind, we have tons of readings for every single core network segment that comes in where we know the speed. So that gives us such powerful averages. We call them historical norms. So that's what we determine as recurrent congestion. I can answer. So if you want to have more, I guess I'll say, if you want to have more information on the methodology for this, or if you're interested more, you can Google Penndot TSMO, and it's all listed out there in 2 pages on our performance report that we released in January 2020. So getting into COVID-19, and maybe you've heard some conversations on the traffic volume drops, etc. I've probably read some news articles, but I'm going to relate this to the DOT perspective. I'll give you a little more information as it kind of impacts everybody and relative to some other things that it affects outside the DOT. But what we saw here and what you're looking at on the left is crashes. So these are Waze crashes being recorded in the blue line. And then you have the truck volume, and then you have the passenger vehicle volume in green. So orange being truck and passenger in green. Now, through a partnership with our Bureau of Planning and Research, they gave us the availability to see the traffic counts from the permanent count station. This was very important to our traffic engineers. So as we all know from the Pennsylvania perspective, back in March, we had non-essential business closures, non-life sustaining business closures, and then stay-at-home order. So this caused a major downturn in everybody traveling, rightly so. So this also impacted Waze crashes. Approximately 88% of Waze crashes actually decreased during those months where everybody was kind of more staying at home. But this gave us an insight. So whenever there's a drastic change like that, it gives you an insight to actually reevaluate your business practices. So what we wanted to look into is, okay, back in March, we had a cease and desist on all Penndot construction. We know from the Penndot construction perspective that it's been heard or it's been exclaimed from our TMC managers that our policy and the way it's kind of called into our TMCs 15 minutes beforehand is very intrusive to their daily business. And they can't work on multiple calls, and if they have an incident going on in rush hour, etc. So construction resumed May 1. Oh, I always get ahead of myself on this. I'm sorry. So construction resumed on May 1, and I'll pick back up there. But what you're seeing here is a tool that we developed with the Bureau of Planning and Research that we hope to make available sometime soon. This gives you the availability to look at the traffic volumes by day of week and certain hours of the day, so you can understand the traffic differences, and you can compare that to the 2019 data. So we've seen upwards in the beginning, in the height of this back in the April time, that 50 to 60% drops in traffic volumes throughout April on some of our major corridors, for example, on I-83. So this is something that we hope to have coming soon to our engineering districts, so that they can look at. But getting back to what I was talking about, sorry about that. I should probably switch the order. But from our TMC perspective, the intrusion of the actual construction costs. So what you're looking at in front of you right now, on the left axis, you see 0.2, 0.4, 0.6. That is a ratio. So that is the ratio of the amount of incident management or RCRS entries per Waze crashes that were entered. So what we found that pre-COVID, we were averaging Waze crash entries into RCRS approximately around 20 to 23% of the amount of Waze crashes that were coming in. Now, keep in mind, that was also 88% more than there was after that March 16 drop. But after that 88% drop and construction kind of went away, we saw a significant increase in the amount of verified Waze crashes that we were receiving from our operators. Approximately, I think it was around 58% on average, that the amount of crashes that came in were then verified, but through a Penndot database. As after construction resumed, we went back out slightly higher, approximately around 30% of the Waze crashes. Now, keep in mind, the Waze crashes did not go up after this. They stayed consistent since March through May. So the only variance here was when construction resumed, and the operators were kind of being, maybe slightly overburdened. So we validated the aspect of what we heard from our individual TMC managers. So what Brian already talked about, I'm not going to get into this too much, but we're looking to develop a mobile app that will allow us to turn on, turn off work zones out there. It will be available on Apple iPads, for example, and it's going to also allow our traffic management centers to be more proactive and improve the safety out there for the motoring public and our workers. One final thing, I believe it's the final thing that I'm going to cover. So our office is also taking a look at understanding the impact of COVID-19 on revenue. So as with any downturn, there is an impact on the amount of gas that is sold. So what we did was develop this model, per request that we received from our deputy secretary to understand funding going forward. So basically, what we did is we took a look at the revenue amounts that we had for the last 10 years, and we looked at our data sources, and what we found is that revenue has stayed almost consistent to 1% over the last 5 to 7 years. So that gave us the ability to do a comparative analysis all the way back. We know our tax rates. Sorry to say, Pennsylvanians, we have the second highest tax rates for gas and diesel throughout the nation, when we're only second to California. But then we also have our traffic counts, and we have data sources via INRIX that gave us a temporary VMT estimate that we plug into this model. So we've been doing this for a while. We understand that 97% of the fuel tax revenue comes from gas and diesel sales, but we've been providing a shortfall report to the executives up to the secretary to understand where we're going forward, because that's the only way we can keep business moving, is if we can understand what we can budget as we go forward. So as we go forward, from the performance perspective, we're working on automating protection messaging, specifically whiteout conditions or snow squalls, and have those messages automated. So we have to understand the certain weather station data and what causes those conditions to our motorists. AAA recently said that is the most dangerous condition, winter weather-wise, for individuals to drive through. As you probably hear about once in a while, there's 30 to 40, 50 car pileups. A lot of times they're caused by snow squalls and the drastic changing of conditions. We're working on an operationally deficient roadway measure. It's supposed to go, it'll coincide with a congestion pie chart. It basically drills down the understanding of where they could potentially look at making an intelligent transportation solution. And then we'd like to have an incident clearance time dashboard by municipality for our operators, for our responders out there. These are the guys that have to go out there every day to respond to the crashes. So we want to give them the availability of the information that we have. So that's something we're working on right now too. So I think that's it, Danielle. So if there's any questions.
Yeah, thank you. Great presentation, a lot of wonderful information in your presentation there. We have a few questions that came in, so I'm going to transition things over to Dan.
Okay, Ryan, we got one question in for you, and then as we're waiting for others to come in, I might also pepper some questions out to our prior speakers to circle back with them on things that we didn't get to.
Sure.
So Ryan, question for you is what type of trends in traffic volumes have you seen recently?
So our most recent data for the month of October showed traffic volumes on the core network that I spoke about down approximately 10% on average. Now at the height of this, we were around 35 to 40% on the core network, and then we've steadily gone up since then. Well, yeah, I would say most recently on the core network, on average, 10 to 12% down for traffic volumes.
Okay, the next question goes back to Brian Crossley. It involves something that Brian, you'd said towards the end of your presentation. The question is how does the autonomous vehicles recognize hills and curves so it doesn't get struck from behind?
So what happens with an autonomous TMA or any type of autonomous vehicle? It is dependent on the lead vehicle in front of it. Usually they're retrofitted with equipment that what it does is it drops what they call e-crumbs. And what's going on then is that autonomous vehicle is going behind it and gobbling up these e-crumbs at kind of a ranged, predetermined range of speed and following distance. So, and what happens in the case, say out in like Colorado, they showed us that the equipment is in this case mounted in the back cab of the paint truck, and there's an operator that's monitoring that program and how it's communicating to the autonomous vehicle following behind. So he could actually make adjustments as they're going traversing different terrains. He could essentially tell it to come to a stop or creeping pace until they get over a knoll, and then he can communicate back to it that it needs to speed up to catch up. And then once it gets to the threshold of where they determine this is the minimum distance you're going to have between yourself and the lead vehicle, it'll automatically, once it gets to that range, it'll slow down to the travel speed that the lead vehicle is following.
Thanks, Brian. Actually, the next question is Kevin and Ted. As it pertains to UCC, is security an issue?
I don't believe it is an issue. You have to have permission to view anything. So even if you had a login or whatever, you would have to have admin rights to be able to change anything, even if you can view things. So you have to be given specific permissions in the program in order to change anything and even to view it.
Next question's going back to Ryan. Ryan, how many areas are you seeing that are developing a TIMS, Traffic Incident Management System, task force that you are working with to share these type of notification tools?
So there's a lot of TIMP teams that are established around the state. I mean, we're always trying to get more. So primarily we're working with our Pittsburgh region, so our District 11, on developing this right now because they'd like to share this information with their municipalities and their TIM responders. It's going to be available to everybody, though. We want to make sure we have liaisons within all of our traffic management centers that are effectively working with or establishing TIM teams. So District 6 also is very, very heavily involved in this as well. I think I roundabout answered your question. So no one effectively is using that information yet, but we're going to try to make it available.
All right, thank you, Ryan. We are going to leave the chat pod open for a little bit yet. We're about 10 minutes till the top of the hour. So if you do have any questions for our presenters, please type them in the chat pod. A few additional housekeeping items, just as a reminder, the recording of this session will be available on our event website within the next week or so. That event website again is www.penndot.gov/innovationsweek. You can also click on the link, the participant link that you received in the calendar invite for today's session, and you'll be able to hear a playback of the recording as well. That's another option for our attendees, especially if you missed some of the earlier presentations. Again, another plug for our virtual exhibit hall, which is available on our event website. We have more than 50 innovations out there from federal, state, and local agencies. Encourage you to go and check out these exhibits. Also, we have a contact form out there. So if you do have a question regarding any of the innovations that are on display in our virtual exhibit hall, use that contact form to submit those questions and we'll get you connected to the subject matter expert. So I'll go back to Dan real quick just to see if there are any more questions that came into the chat pod.
I have not.
Okay, we're going to give it a few minutes yet. Again, if you do have any questions, please type them into the chat pod. And then we'll go to the presenters for any additional comments they may have before we conclude today's session. Again, we just got a question regarding the recording of the session. So two ways that you'll be able to access a recording of today's session. We will be putting a link to the recording on the event website within the next week or so. Again, that's www.penndot.gov/innovationsweek. The other way you can access a recording of today's session is in the calendar invite you received for the session today. Just click on the participant link and you'll be able to listen to a playback of today's session. I don't believe we got any other questions in at this point, so I'm just going to go to any of our presenters if there's anything that you would like to add or any final thoughts that you have regarding anything that was discussed today. Okay, well, I would like to thank all of our presenters for taking time out of their incredibly busy schedules to present on some very innovative topics today. There's a lot of great things that are happening across the department, a lot of tools in the toolbox that are available or will soon be available to our folks across the department and municipalities. So my thanks to all of our presenters for their time today. Also my thanks to all of our audience members. We very much appreciate you all joining us today, and we hope you have a wonderful evening. Thank you.